Morning, everybody. I wanted to go through a couple things with you real quick this morning. The first thing I want to talk with you about is how colors of light interact. Remember, color of light is based on the frequency of the light, and all light moves at the same speed in a vacuum, but different frequencies of light will have different energy, and that'll also give you different colors. What we're looking at today is red, green, and blue, and those are the primary additive colors for light. And if we look at this setup I have right here, you'll notice I have a red and a green light. I have them going through this lens, and I have them intersecting, kind of like a Venn diagram there. And what you notice is where those two colors overlap, you get yellow right in the middle. It's a little hard to see because it's a little washed out on the video, but it's more of an orangey yellow when you look at it in person. Now, if I change the lights that I'm using, and I go to red and blue, what you'll notice is where they overlap, well, can't get it to work, is we end up with this magenta color. So red, and blue give you magenta when they overlap in the center. And then if I take, of course, green and blue, they're going to give you that sky blue color that most of you are familiar with, which is called cyan. If I can get them to line up. There we go. So you see that color right in the middle, that sky blue color is called cyan. Now, most of you already know this too. If I take all three of those colors and line them up together, when we mix red, green, and blue, we end up with that spot in the middle, which is just white. So white light is a combination of all the other colors of light. Now, something else I wanted to show you with this setup is called Snell's law. When you take a light and you pass it through a medium, like glass, that glass causes the light to change speed. Now, if you look at this as it's set up, you can see the laser. Let me turn these off. You can see the laser coming from here. It's going right here. It's going through the glass. And that's where it would continue. But if I block where it goes over the glass, you can see how it doesn't line up on the other side. See how this is where it would continue. But when I block it, that's where it actually comes through the glass. So that light is being bent here as it goes in the glass, and then again here as it comes out of the glass, which causes it to shift over to right here. And that's based on the change of speed of light as it passes through a medium that's more dense than a vacuum. That's all for today. Talk to you later.